Look down at your wrist right now. If you are wearing a modern smartwatch or a fitness tracker, take it off for just a second and look at the very back of the device. You will likely see a tiny, rapid, flashing green light. It looks like a tiny laser beam straight out of a science fiction movie. We strap these little computers to our wrists every single day, completely trusting them to tell us how many calories we burned, how well we slept, and exactly how fast our heart is beating during a grueling morning run or a stressful meeting. But if you stop to think about it for a moment, it makes almost no sense. When you go to a hospital, a doctor uses a tight, squeezing air cuff on your arm, or a cold stethoscope pressed directly against your chest to listen to your pulse. So how in the world does a flat piece of glass and a little green LED light resting gently on top of your arm actually know what your vital organs are doing deep inside your chest? Is the watch just making a really good educated guess based on how much your arms are swinging while you walk? Or is there real accurate medical science happening right there on your wrist? Today we are going to look behind that glowing green glass, strip away the complicated medical jargon, and break down exactly how your smartwatch measures your heart rate step by step, so you know exactly what is happening every single time you check your pulse. To understand how your watch sees your heart, we first have to talk about the physical nature of your blood and a little bit of basic color physics. We all know that human blood is a deep red color. But in the world of physics and optics, the color of an object dictates how it interacts with different colors of light. Because your blood is red, it naturally reflects red light, which is exactly why it looks red to our human eyes when we get a paper cut. However, because it reflects the color red, it absolutely absorbs the opposite color on the visible light spectrum, which happens to be green. This simple, unbreakable rule of color absorption is the fundamental secret behind almost every single optical heart rate monitor on the market today. The scientific name for this specific technology is photoplethysmography. That is a massive, incredibly confusing scientific word, so engineers and doctors just call it PPG for short. But the actual physical concept is remarkably simple to understand. Your smartwatch is essentially acting as a microscopic flashlight and a tiny digital camera, working together seamlessly to look at the blood flowing just beneath the surface of your skin. Let us look at what happens inside your body when your heart actually beats. Your heart is a powerful organic pump. When it squeezes, it forces a massive surge of fresh, oxygen-rich blood out into your body, down your arms, and directly into the tiny, microscopic blood vessels in your wrist called capillaries. For a split second during that powerful squeeze, the total volume of blood in your wrist drastically increases. Then, a moment later, as your heart relaxes to fill back up with blood for the next beat, the blood volume in your wrist temporarily drops back down. This continuous rhythmic pulsing of high volume and low volume happens dozens of times a minute, every single minute of your entire life. Now, let us bring that flashing green light on your watch back into the picture. When you strap your smartwatch onto your wrist, it shines that bright green LED directly into your skin. The light easily passes through your translucent outer layers of skin and illuminates the tiny blood vessels sitting right underneath. Remember our golden rule about colors. Red blood absorbs green light. When your heart pumps and sends a large surge of blood into your wrist, there is suddenly a lot more red blood sitting right under the watch. Because there is more blood present in that exact millisecond, a large amount of that green light is instantly absorbed by the blood, meaning very little light bounces back out. A fraction of a second later, when your heart relaxes and the blood volume drops, there is less red blood in your wrist. With less blood to absorb the light, a lot more green light successfully bounces off your internal tissues and reflects straight back up toward the watch. Sitting right next to those glowing green LEDs on the back of your watch is a highly sensitive electronic component called a photodiode. This is essentially a specialized digital light sensor. Its absolute only job is to constantly measure exactly how much green light is bouncing back from your arm. As your blood volume pulses up and down, the amount of reflected green light constantly goes up and down with it in a perfect rhythm. The smartwatch's internal computer processor takes this continuous fluctuating wave of light data and runs it through a highly complex software algorithm. The processor simply counts exactly how many times the light absorption peaks and dips every single minute. If the light dips 60 times in 60 seconds, the watch instantly calculates that your heart is beating at 60 beats per minute, and it throws that number right up onto your digital screen. It is doing this light speed calculation hundreds of times per second, but engineers faced a massive problem when designing these watches. What happens if you are running wildly, swinging your arms, or sweating heavily? That movement causes the watch to bounce around on your skin, which lets ambient sunlight leak in and completely messes up the delicate green light readings. This is known as a motion artifact. To fix this, modern smartwatches use built-in accelerometers to track the exact physical movement of your arm. The software uses artificial intelligence to instantly subtract your physical arm swinging from the light sensor data, filtering out the random noise to find your true heartbeat hiding underneath. It will even automatically adjust the brightness of the green light depending on your skin tone, or if you have thick tattoos, to ensure the light penetrates deep enough to get an accurate reading. You might have also noticed that sometimes, especially at night when you are sleeping, your watch stops flashing green and switches to a faint red or invisible infrared light. Green light requires a lot of battery power and can be very distracting in a dark bedroom. When you are completely still during sleep, the watch does not need to fight through heavy motion artifacts, so it switches to infrared light. Infrared light penetrates human skin much deeper and uses significantly less battery power, allowing the watch to silently track your resting heart rate and sleep stages all night long without draining the battery before you even wake up. So, the next time you finish a heavy workout, wipe the sweat from your forehead and glance down at your wrist to see your heart rate. You will know exactly what incredible science is happening. It is not just making a wild guess based on your movement. Your watch is actually shooting specialized light into your body, reading the microscopic color changes of your pulsing blood, filtering out the physical movement of your arm in real time, and doing massive mathematical calculations just to keep you informed about your cardiovascular health. If this simple breakdown helped you finally understand your wearable technology, hit that subscribe button, give this video a quick thumbs up, and leave a comment below telling me your absolute favorite smartwatch feature. Thanks so much for watching, and stay healthy.